So now we're going to talk about some higher order derivatives, still kind of using some of the concepts that we learned before, but also using our calculator a little bit. So consider this function, f of x. Find f prime of 0. All right, so f prime of 0, first I should find f prime of x. F prime of x is 6x plus 5. F prime of 0, plugging in 0 for x, is 5. Harpisa's graph f on your calculator, find f prime of 0 and then f prime of 1. And to do this, you can see the calculator commands. All right, so if you're in stats, turn off your plots. So we're plotting f of x, not f prime. 3x squared plus 5x plus 1. We want to find the derivative at 0 and the derivative at 1. So if you go into the second, it's bigger, sorry. If you go into the second calc menu, second trace, you can see dy dx. We want to find the derivative at which x value, so let's get that out of the way. At which x value, so you have to type in, the first one was at 0, press enter, and it tells you dy dx equals 5. That confirms what we got, right? So that's equal to 5. F prime of 1, do the same thing. I don't think you can just, well, let's see, can I just, no. I tried to just type in 1 again, but no. Find dy dx at 1, and it tells you that's 11. So we can find that on our calculator. There's another way in your calculator that you can calculate a derivative, and it would be if you're not looking at the graph, you can just do it right on your home screen. So, all right, I have the equation typed into y1. That's great. Quit to the home screen, so second mode. If you go into math and scroll down the line here, option 8 says n-deriv. Now, if you have a newer calculator, this is so nice because it kind of tells you the setup here, right? You need to tell it you're taking the derivative with respect to what variable. That will be x all the time for us. And then you put your function in here. The function f of x was 3x squared plus 5x plus 1. And then down here, you want to evaluate when x equals, what did they just ask us to do? Just when x equals 1. We get the same thing, get 11. If you don't have a calculator that has this math type, so like if you have an 83 or an older 84, then in these notes, you can see you have to, in parentheses, type your function, separate with a comma, tell it with respect to x, comma, put in the 1. You can also, if you didn't want to type out this entire equation, actually, sorry, clear this out. You can go to math 8 with respect to x. Remember, the equation is sitting in y1, so I don't know that this is any faster. But if the equation is really complicated and you've already typed it into y1, you could also do vars, y vars, function, y1. Same thing. Okay, so you have some options here. Use your derivative in part A to check that f prime of 1 is your answer in C. So our calculator is telling us 11. Does that check with what we have algebraically? So f prime of 1 is equal to 6 times 1 plus 5. So yeah, it checks out. Which feature is more useful when finding the derivative at any point? What does that mean? That doesn't mean find the derivative at just 1 or just 0. It means finding f prime of x. Well, the calculator isn't going to find f prime of x for you. It has to have a point to plug in. So algebraic. Now, if we're talking about what if they actually evaluate a point? So like what this question might be getting at is on your screen, if you're on the graphing screen, I believe if I try to find a derivative outside of this window range or outside of the piece of the graph I can see, I don't think it's going to find it for me, but let's find out. So let's say I want the derivative when x equals 30. No, we won't go that extreme. Let's just go right off. So off of our window would be like 4. Oh, no, it did find it for me. Okay, let's go outside of our window just to double check. 11, because the window's to 10. Okay, yeah. So when you're outside of your domain range, your window domain, that's where it doesn't like that. If I do this on my home screen, let's see if it lets me do 11 down here. Yeah. So the home screen is good if you're trying not to be locked into a certain domain based on the calculator screen. But if the question is just find f prime of x, I can't do that on the calculator. So do either of these features give you the derivative of x? I guess that's what I guess that's what this question was really asking. So no. Find f prime of x, the equation for f prime of x, algebraically. Which feature is more useful in finding a derivative at any point, let's say x equals c? Okay, that would be the home screen, which is math, 8, etc. So your calculator can evaluate derivatives, derivatives at any point x equals c. Your calculator cannot find an equation f prime of x. At least the 84s can't. I don't know about the Inspires and all the other fancy ones. Find the following derivatives. All right. Here's f of x. Let's find f prime of x. 8x cubed minus 3x squared plus 10x plus 3. This little notation, f double prime, you could read it like that, f double prime of x, it means take the second derivative. So take the derivative of the derivative. Let's just take the derivative of f prime. So 24x squared minus 6x plus 10. Take the third derivative, the derivative of the second derivative. All right, 48x minus 6. There's no limit to how many derivatives I can take. I could take a fourth derivative. It would be 48. The fifth derivative would be 0, and every derivative after that would be 0 for this particular problem. Let's go down to b. The original function is 4 times sine of x. Here's different notation. Find dy dx. All right. Derivative of sine is cosine, so that's 4 cosine x. The second derivative, when it's written in terms of dy dx, is this. D squared y dx squared. Why is it like that? Because technically it's d dx with respect to y times d dx. Those are both with respect to y. So technically d squared dx squared with the y in there. All right, anyway, derivative of cosine is negative sine, so this will be negative 4 sine x. And the third derivative will be negative 4 cosine x. There's no end. It's just going to keep cycling around. The fourth derivative would get us back to positive 4 sine x, and then on and on and on. So there's a cycle of 4 for the sine and cosine derivatives. For C, this equal sign got erased. That's not a subtraction. What is y prime? Remember, we don't know product rule yet, even if you learned it in another class. Plus, also, it'd be silly to do product rule when you can easily, anytime you have a monomial times something, don't use the product rule, just distribute. X cubed plus 4x squared. So the first derivative is 3x squared plus 8x. The second derivative is 6x plus 8. And the third derivative is 6. The fourth derivative would be 0, and the fifth derivative would be 0, etc., etc. We don't know the quotient rule, and again, it's silly to use quotient rule even if you do know it. when you have a monomial in your denominator. Instead, just divide. X, each term gets divided by x, plus 2 minus, instead of 1 over x, let's write that as x to the negative 1. The derivative with respect to x of f of x is 1 plus x to the negative 2, right? Because it'd be negative 1 times negative 1 is plus, negative 1 minus 1. So I'm going to write that as 1 over x squared. All right, the derivative of 1 is 0. This is x to the negative 2, so it'll be negative 2 times x to the negative third, or over x cubed. This is negative 2x to the negative 3, so the derivative will be positive 6 over x to the fourth. And you could keep going with this. There's not going to be an end where it gets down to 0 for this problem. Back to position and velocity for a little bit. So the position function for falling objects on the moon is given by this position function. Find the acceleration due to gravity on the moon. Acceleration is the derivative of velocity. Velocity is the derivative of position. So the second derivative of position should be the acceleration. A of t should be s double prime of t. All right, so let's see. S prime is equal to negative, oh gosh, math, 1.62 t, that's a struggle. And then the derivative, second derivative of that is just negative 1.62. And that's a constant acceleration. We don't have anything to plug into it. So A of t is negative 1.62. What would our label be on that? Originally we were in meters. Velocity would be meters per second. And so acceleration is meters per second, or meters per second squared. Graph the absolute value of x. Okay. Absolute values in math, over to number. Absolute value. X, graph this thing. Done. Use the dy dx feature to find f prime. So on your graphing calculator screen, I want to find f prime is 0. So let's see what happens here. Second, trace dy dx when x equals 0. It tells us dy dx is equal to 0. Is that correct? Is f of x differentiable at x equals 0? We should be saying, no way, sharp turn, not differentiable. So the calculator is leading us astray. That's a problem. So don't believe your calculator 100% of the time. Also use your knowledge of calculus. What if I do this on the home screen? So what if I use nderiv? So what if I quit to my home screen and find the derivative of the equation I have in y1 at, what did we say, 0? It gives us 0. Same false information, right? It's like sabotage. So, do these answers make sense? No. What is the derivative of f of x equals 0? There is no derivative. F prime of 0, no solution. Think about the graph, the derivative graph for f prime of x. At x equals 0, to the left of x equals 0, the slopes were negative 1. To the right of x equals 0, the slope is 1. There's a jump in that graph. At 0, the slope is neither 1 nor negative 1, so there is no derivative at x equals 0. Why is our calculator getting it wrong? It's using a symmetric difference quotient to figure out the derivative. So remember we said, hey, the slope of a secant line, if we make that really small, becomes the tangent line. Your calculator finds a secant line that would be parallel to the point of tangency, comes up with its best approximation. So now this is another way to find a derivative. You're not going to have to do this for calculus, so don't like store this away in your brain as something you're going to do. The problem with the absolute value graph is there are all kinds of points at which you can find a secant slope that would be parallel to a tangent slope right here. And all of those secant slopes are coming out to be 0. So it's telling you that the tangent slope is going to be 0. So why explain all of these secant slopes equals 0, and they are parallel to the tangent line at x equals 0. So that's why it's getting it wrong. Find the equation of the tangent line at x equals 3 for each function. So without a calculator, let's do that. I don't know chain rule yet, so I don't want a chain rule. So why am I writing f prime? So I want to rewrite f of x. I want to square this out. 4x squared plus 6x plus 6x plus 12x plus 9. The derivative is 8x plus 12. The derivative evaluated at 3 is 24 plus 12, 36. For this one, let's use a calculator. If I didn't have a calculator, I would distribute and solve. Let's go ahead and use a calculator. I prefer the home screen just because, I don't know, why put it into Y1 and then have to adjust a window? So this was x cubed, 4x squared minus 17. We want to evaluate and set at x equals 3. So if you were doing this on a calculator portion of the test, you would simply show g, for a calculator portion, you would just say g prime of 3 is about equal to, there's nothing to show, you would just put down your answer, 1,161. We always round to 3 places for calculus, so 0.000. H of x equals 5x squared minus 7, using either limit form of a derivative. Ugh. All right, well, do we want to use the definition of a derivative, the limit definition, or do we want to use the alternate form? Well, ultimately, we're trying to find h prime of 3. So remember, it is way faster to use the alternate form rather than find the equation, then plug 3 into that. So let's use the alternate definition. We have to watch our notation. It's the limit as x approaches c, in this case it's 3, of f of x minus h of 3. What is h of 3? Let's figure that out off to the side. 5 times 9 is 45, minus 7 is 38. All over x minus 3. Let's work on this a bit. Limit as x approaches 3 of 5x squared minus 45, so minus 3, equals the limit as x approaches 3 of, so this is going to be 5 times x squared minus 9, which will factor into x plus 3x minus 3. Those cancel. Since those cancel, it's now safe to do direct substitution. Drop your limit notation. 5 times 6 is 30. All right. Find the first derivative, the second derivative, and the third derivative. All right. F prime of x. The derivative of sine is cosine. The derivative of pi to the third, that's a constant. We're trying to trick you. That's 0. So the derivative is just cosine x. The second derivative of cosine is negative sine x. Third derivative of sine is cosine. There's a negative out in front, so negative cosine x. Let's divide by x to the fourth and write negative exponents so that we can easily take derivatives here. X to the negative 2 plus 3x to the negative 3 minus 5x to the negative 4. dy dx, just to use different notation, is negative 2 x to the negative 3 minus 9x to the negative 4 plus 20 x to the negative 5. Should I rewrite that? Yeah, I'll do it eventually. Derivative of that is 6 x to the negative 4 plus 36 x to the negative 5 minus 100 x to the negative 6. Finally, third derivative, negative 24 x to the negative 5 minus 3180 x to the negative 6 plus 600 x to the negative 7. Pause this.